This is lesson 1.4 on the quadratic formula. Right, in general, quadratic equations are going to be of the form ax squared plus bx plus c, where a, b, and c are any real numbers. Now, in the last section, we looked at some specific quadratic equations. Those are ones that worked out so that it was fairly easy to factor them. As I mentioned before, that's not always the case. Furthermore, we have only seen and will continue to only see quadratic equations where our coefficients in constant terms are integers. So in other words, a, b, and c are all integers. That does not have to be the case. Just for simplicity's sake and ease of calculation, we are going to continue to see quadratic equations with integer numbers, integer coefficients and constants, but please keep in mind that that is not always going to be the case. Now, the quadratic formula, which we've probably seen at some point in our math career, and we're actually going to see in a moment how to derive the quadratic formula, is given by the equation stated here. This is going to tell us that there are three different scenarios that can occur. We're either going to have two real solutions. That's going to occur when our b squared term is greater than the 4ac term. We could have one real solution. That will occur when b squared equals 4ac. And there's also the possibility that we'll have two complex solutions. That will occur when b squared is less than 4ac. Now, just to remind you about what we mean with a complex number. A complex number is any number with an imaginary portion to it. So in other words, we have an I pop up. Remember, I, that's just our shorthand of writing the square root of -1. Generally, we want to avoid this. However, in certain circumstances, we are going to allow for complex numbers. Here with these problems where we are using our quadratic formula, this is going to be one situation where we will allow for complex solutions. Just a reminder of how to reduce these terms into proper form. Take for consideration this example here, the square root of -24. Think of it as -1 times 4 times 6. That -1, when we pull it out of the square root, becomes I. The 4 becomes 2 when we take it out of the square root. Again, the square root of 4 is 2. And the 6, that is not a perfect square. We can't reduce it, so we leave it inside the radical. So the proper way to reduce the square root of -24 would be 2i square roots of 6. Before we take a look at how we derive our quadratic formula, I need to demonstrate an additional technique that you can use to solve quadratic equations. This is a technique called completing the square. I'm not going to spend too much time on it simply because it's basically the same as the quadratic formula. This technique, however, we will see again. We will need to use it in Chapter 2, so pay attention, make sure it makes sense, but be aware that we will not need to use this particular technique at this moment. I'm simply introducing it so that we can see how we derive our quadratic formula. Completing the square, what we need to do is we need to write our terms that contain our variables as a perfect square. So what I'm going to do is I'm going to separate my terms with x values. I'm going to move my constant term 3 over to the other side of the equation. So this is very unusual. This is the exact opposite of what we'll normally do when we're wanting to solve a quadratic equation by either factoring or our quadratic formula. So I've isolated my x terms, and my constant term is on the other side of the equation. What I'm going to do now is my coefficient of my squared term, I'm going to factor that out. I am not going to factor out an x term. That's a common mistake. I will not do that. I'm only going to factor out that 2. So when I factor out the 2, this will become 2 times x squared plus 2x. And on the right-hand side, rather, I still have 3. Notice I just factored this out. I'm not actually multiplying this out of the blue, so that's why I'm not multiplying this side. The goal here, I want to write what I have in the parentheses here as a perfect square. X squared plus 2x plus something. I'm always going to add something to complete the square. The something that we will always add is going to be half of this number, half of the coefficient of x squared. So half of 2 is 1. 1 squared is 1. So I'm going to add 1 here. But I can't just add 1 out of the blue. In actuality, I haven't added just 1, have I? I've added a 1 here, but it's inside parentheses that are being multiplied by 2. So in actuality, I've added 2 to the left-hand side of the equation. So to keep everything balanced, I must add the same amount to the right-hand side. So the whole point of doing this, x squared plus 2x plus 1, that is in fact x plus 1 quantity squared. If you don't believe me, check it, FOIL it real quick. You will in fact get x squared plus 2x plus 1 back. So my equation is now 2 times x plus 1 quantity squared equals 5. I want to get my x by itself. I want to solve for x. So I'm going to divide both sides by 2 first. It's going to give me x plus 1 squared equals 5 halves. Now I'm going to take the square root of both sides. Remember, when we take the square root of both sides of an equation, you must put in this plus or minus. So the square root of x plus 1 squared, that is simply x plus 1. Square root of 5 over 2. What we need to do to simplify this is we're going to multiply top and bottom of this fraction by 2. So that will give me the square root of 10 over 4. The reason we do that is because 4 is a perfect square. So we can now write this in this way. And last but not least, I subtract 1 from both sides, leaving my x by itself. So my final answer is this. X is negative 1 plus or minus square root of 10 over 2. Once again, we will not need to use this technique for this section. Chapter 2, we will need to use a similar technique, but now I'm simply introducing this so that we can see where we get our quadratic formula from. Okay, so suppose that we don't want to solve that specific quadratic. Suppose we're told to complete the square to solve this general quadratic. It looks scary, it seems scary to use that same technique where we don't actually know what our numbers are. But it's okay, we're going to use the exact same process to find the solution. So remember, the very first thing we did is we isolated our terms with our x's. We took our c to the other side. Next, recall that we factor out the coefficient of our squared term. So I'm going to factor out an a from the left-hand side. So ax squared, when I divide it by a, I'm factoring out the a, so to find what I put inside the parentheses, I divide the old term by a. So ax squared divided by a is just x squared. Bx divided by a, that's going to be b over a times x. I'm going to leave some space here because I know that I'm going to be adding something to complete the square. If you recall what we need to add, it's going to be half of the x term, so half of b over a squared. So just over here on the side, half of b over a. We're just multiplying two fractions, so that's going to be b over 2a. And then we need to square that. B over 2a squared. Or to square a fraction, you just square the top and the bottom parts individually. So b squared over 4a squared. So that is the term I need to add here. Looks scary, it is a little scary, but don't worry. You won't need to do this on your own. I just like to show my college algebra students where this formula that they know and, I don't know, hopefully maybe not love, but at least appreciate comes from. All right, so remember, just like last time, we haven't actually added b squared over 4a squared out of the blue. We've added that times a. So a times b squared over 4a squared, because we have an a, basically think of this as a over 1. So you have an a in the numerator, a in the denominator, so one of those powers is going to cancel out. So that leaves us with b squared over 4a. So since I've added basically b squared over 4a to the left side, to keep everything balanced, I need to add b squared over 4a to the right-hand side. Okay, so back on the left-hand side, the whole point of doing this is so that I can write this as a perfect square. I have x here, so my first term in the binomial will be x. The next term is always going to be half of this number here. So we saw before that that's going to be b over 2a. So once again, if you don't believe it, FOIL it out real quick. Sure enough, you are going to get x squared plus b over ax plus b squared over 4a squared back. All right, on the right-hand side, I'm going to, it seems a little bit extra work right now, but it's going to be pretty clear here in a few moments. Let's get a common denominator of 4a here. I'm actually going to write this b term first. So b squared over 4a. All right, so this negative c term, it's negative c over 1. So to get a common denominator, I'm going to multiply top and bottom by 4a. That's going to make the numerator of that term 4ac. Okay, I want to solve for x. So the next thing I need to do is divide by a. So that gives me x plus b over 2a on the left-hand side. Dividing by a on the right-hand side gives me b squared minus 4ac over 4a squared. And then next, I have something squared on the left-hand side, so I'm going to take the square root of both sides. But I do not forget to take plus or minus of the square root of my constant term. So on the left-hand side, I have x plus b over 2a. On the right-hand side, I have a nasty-looking square root. That is not pleasant looking. Let's see if we can simplify it a little bit. Remember before when we said that the square of a fraction, we just square the top and the bottom individually? Same idea works for the square root of a fraction. We can just take the square root of the top and the bottom individually. That upper term, that looks kind of nasty. It is. There's actually not a good way to simplify that upper term. So I'm just going to leave it the way it is. Square root of b squared minus 4ac. All right, our bottom term, however, works out to be a lot more pleasant. 4a squared, the square root of that is going to be 2a. All right, finally, I want to get x by itself, so I subtract b over 2a from both sides, which is fortunate because the denominator on the right-hand side is already 2a, so I can fairly easily write it as a single fraction. And when I do, lo and behold, we get our familiar looking quadratic formula back. So this is how we derive our quadratic formula. It's actually using the technique of completing the square, but it's in some ways much more efficient just to use the formula than actually going through the technique of completing the square. All right, so let's do one quick example of using the quadratic formula. Now one indicator of when it might be a good idea to use your quadratic formula as opposed to trying to factor is if the numbers just, for lack of a better feeling, you just have a gut feeling that things aren't going to work out right. You're pretty sure that things don't, the numbers don't work out right as far as the products equaling something and at the same time adding up, or their difference being this constant term. So if you don't have it memorized, remember that we need to have our quadratic in this form. We always have to have everything equal to 0. Once we're in that form, we know that our solution is going to be this, negative b plus or minus the square root of b squared minus 4ac all over 2a. So the very first thing we need to do here is to get our problem into this form. That's just a matter of moving this 5 over to the left-hand side. So when we subtract 5 from both sides, it's plus 13x, 36 minus 5, that's going to be 31. So we are now in perfect form for using our quadratic formula. So remember, if we don't have a number here, that's an implied coefficient of 1. So 1 is our A, 13 is our B, 31 is our C. Some of these numbers are going to be less than pleasant. They're going to wind up giving us some fairly large numbers. I am willing to be somewhat lenient in some certain circumstances on our drill problems. I will generally try to give you problems where the numbers work out so they're not going to be nice, but hopefully not heinous. But if you're working through things and it's just not working out, go ahead. Don't spend 2 or 3 minutes trying to work out this perfectly. Be very efficient with your time. If you can show me that you can plug in the numbers correctly to the quadratic formula, if it in fact wound up being a problem where the numbers were just terrible, I'm probably going to be inclined to go ahead and give credit for just showing me what it looks like with the numbers plugged in correctly. So in this situation, our solutions are going to be x equals negative b, so negative 13, plus or minus the square root of b squared, so 13 squared, minus 4 times a times c. So 4, our a is 1, our c is 31. All over 2 times a. In this case, it's just 1. So let's go ahead and simplify this the best we can. Square root of 13 is 169. If you don't have a lot of your squares memorized, I'd say up through 15 is pretty handy to have memorized. If not, I'd encourage you to work on that a little bit. So 13 squared is 169. 4 times 1 is 4. 4 times 31, that's going to be 124. All over 2. So we have negative 13 plus or minus 169 minus 124. So we have to just focus on the 69 minus 24 portion. That's going to be 45. 45, if you recall, that's going to be 9 times 5. 9 is a perfect square, so we could factor it out. So our most simplified form for this problem would be this. There we go. 100% perfect correct solution. No question about full credit if you put this on the drill.